Question 6 for today is on momentum. It says a 2 kg object moving at 5 meters per second collides with a 3 kg object at rest. They stick together after collision. What is their final common velocity? Option A, we have 1 meters per second. Option B, 2 meters per second. Option C, 3 meters per second. And option D, 5 meters per second. I'll go over the questions again for better understanding. A 2 kg object moving at 5 meters per second collides with a 3 kg object at rest. They stick together after collision. What is their final common velocity? Now, I'll give a free body diagram and then I'll explain better. It says a 2 kg object. Let's say this is the first object. It has a mass of 2 kg. Of this object, let's call this object A. Now, it is moving at a velocity of 5 meters per second. So let's say it is moving at a velocity of 5 meters per second. They say it collides with a 3 kg object at rest. This is another object. They collide. They meet together, and this has a mass of 3 kg. They collide. This is the second object. Let's say B. They collide. This other body is at rest. So the velocity here is 0. Is at rest. They say what is their final common velocity? In a perfectly inelastic collision, two objects stick perfectly together when colliding, or when they collide together. We use the formula for conservation of mass to solve it. And the formula says m1 u1 plus m2 u2 is equal to m1 plus m2 multiplied by v. m1 u1 plus m2 u2 equal m1 plus m2 all multiplied by v. Now, from the question, we are given the first mass, m1. m1 is given as 2 kg, right? We are given u1. u1 is 5 kg here. u1, that's the initial velocity, to be 5 meters per second. We are given m2 from the question, right? 3 kg. m2, the mass of the second object, to be 3 kg. They say this second object was at rest, so the initial velocity is 0. We have v here, which is the final common velocity, So it's unknown. They say we should find v. And we substitute these values into this formula. We have m1 times u1. m1 here is 2 kg times u1 is 5 meters per second plus m2 u2. m2 is 3 kg times u2 is 0 is equal to m1 plus m2. m1 is 2 kg, m2 is 3 kg. So we have 2 plus 3 all into v. 2 times 5 will give us 10 plus 3 times 0, we have 0. This is equal to 2 plus 3 gives us 5V, not voltage, 5V. 10 plus 0 gives us 10 is equal to 5V. If we make V surrogate of the formula here, we have V is equal to 10 over 5. 10 divided by 5 will give us 2. Don't forget the final velocity. The SI unit for velocity is meters per second. So we have V to be what? 2 meters per second. From this option here, the correct option is option B with 2 meters per second. Question 7 says, what is the energy stored in a 100 microfarad capacitor charged to 10 volts? What is the energy stored in a 100 microfarad capacitor charged to 10 volts? Option A, 0.05 joules. Option B, 0.05 joules. Option C, 0.5 joules. And option D, 5.0 joules. Now this is a trick. You see the answers having 0.5, 0.05, you have 0. So anything you get aside 0.5, just know it's off the ball game. Any option you see or anything after solving, anything you get that does not have 5 in it, either as a whole number or as a single value, just know that answer is not correct. Capacitors, this question is on capacitors and energy stored in the capacitors. Now capacitors stores energy in an electric field. The energy stored depends on the capacitance. The capacitance denoted with letter C, and the voltage denoted with letter V. From the question, let's find the key parameters. It says, what is the energy stored in a 100 microfarad? So they gave us what? The capacitor to be 100 microfarad. We have C is equal to 100 microfarad. I keep on telling people, whenever you see this microfarad, it means this one here, it means times 10 raised to the power what? Minus 6. So this is the same thing as 100 times 10 raised to the power minus 6 farad. This micro here, micro stands for what? 10 raised to the power minus 6. It is charged to what? A 10 volts. So we have voltage to be what? 10. 10 voltage. 10 volts. Now, they say we should find what? The energy stored in the capacitor. So energy stored in the capacitor, it's unknown. Recall that formula for energy stored in the capacitor is given as E is equal to 1 over 2 CV square, where C here stands for the capacitance and V stands for the what? The voltage. If we substitute this value into this equation, we have E is equal to 1 over 2. 1 over 2 is the same thing as 0.5 times C. The value for C is 100 times. So we have 100 times 10 raised to the power minus 6 times, here we have V squared. This is V, 10 all squared. This is 0.5 times 100 times 10 raised to the power minus 6 times 10 squared is 10 times 10, which is 100. This is the same thing as 0.5 times. Now let's simplify this. If you observe, let's do it this way. This is, if we convert this to standard form, this is 10 raised to the power 2 times, this is 10 raised to the power 6 minus 6 times, this is what? 10 raised to the power 2. This is from standard form. Here we have standard form. When they have the same base, we pick one and we do what? We add the powers. You observe they are multiplying themselves, so we add the powers. If we pick one, we have times 10. Let's add the powers. We have 2 plus minus 6 plus 2. This is 0.5. This is 0.5 times 10 raised to the power 2 plus minus 6 will give us minus 4. Minus 4 plus 2 will give us what? Minus 2. This is 0.5 times 10 raised to the power minus 2. This is the same thing as 0.5 times 10 raised to the power minus 2 is the same thing as 0.01. Right? Yet 0.5 times 0.01 will give us 0.05 joules. Therefore, the energy stored in a capacitor E is equal to what? 0.05 joules. The correct option here is what? Option B, 0.05 joules. So this is the correct option. Question 8 says, a 10 kg object is pulled with a force of 50 newtons. What is the acceleration? Option A, 2 meters per second. Option B, 3 meters per second. Option C, 5 meters per second. And option D, 10 meters per second. Now, this question, we're going to use Newton's second law of motion because it relates force, mass, and acceleration. We're going to use Newton's second law of motion because it relates force, it relates mass, and it also relates what? Acceleration. From the question, they gave us mass, right, to be 10 kg. So we have mass here to be 10 kg. They said it is pulled with a force of 50 newtons. So they gave us force to be 50 newtons. You see, what is the acceleration? So acceleration here, acceleration A is what? Unknown. From Newton's second law of motion, the formula remains F is equal to ma, where F is the force, m is the mass, and A is the acceleration. Since we are asked to look for A, let's make A the subject of formula here, acceleration. We have A is equal to F over m. If we substitute these values into this equation, we have F over m. F here is what? The force, newtons. So we have 50 newtons divided by, the mass here is what? 10. So we have 10. 50 divided by 10 will give us what? 5. Don't forget, acceleration is measured in what? Meters per second. So we have A is equal to 5 meters per second. The SI unit for velocity is meters per second, while the SI unit for acceleration is what? Meters per second squared. So this is meters per second squared. This is squared, 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 squared. Don't make that mistake when solving. Velocity, the SI unit is meters per second. Acceleration is meters per second squared. Question 9 says, which type of radiation has the highest penetration power? Which type of radiation has the highest penetration power? Option A, alpha particles. Option B, beta particles. Option C, gamma rays. And option D, neutrons. Now, radioactive decay results in the emission of particles. We have the alpha particles. Alpha particles. We have the beta particles. And we have the gamma rays. They differ in mass, charge, and what? Penetration power. Now, for the alpha particles, the alpha particle has low penetration power. It has low penetration power. The beta particle, it has a medium penetration power. Medium. For the gamma rays now, the gamma rays has very high penetration power. Very high penetration power. You can also call this electromagnetic radiation. You can also call it what? Electromagnetic magnetic radiation. This one here, this one is called the neutrons. The neutrons, it has what? Very high penetration power, but it's what? Variable. It varies. So we have its high penetration power, but variable. The question says which type of radiation has the highest penetration power? From what we stated there, we can deduce or we can boldly say that the gamma rays has the highest penetration power. The gamma rays penetrates deeply and it requires a very thick lead to block it. Gamma rays penetrate deeply and requires thick lead to block. So the final answer here, the correct option is option C, the gamma rays. The final question for today, question 10 says, how much work is done in lifting a 5 kg object vertically through 3 meters? Take G to be 9.8 meters per second squared. How much work is done in lifting a 5 kg object vertically through 3 meters? Take G to be equal to 9.8 meters per second squared. Option A, 120 joules. Option B, 147 joules. Option C, 294 joules. Option D, 98 joules. So solution, let's solve. This question is on work, energy, and power. From the question we are given, you see how much work is done. So work done is what? Unknown. They say find it. How much work is done in lifting a 5 kg object? We have mass from the question to be what? 5 kg. It's a vertically through 3 meters. So they give us height. Vertical in the y direction. Vertical through 5 meters. So we have height to be 3 meters. They take G to be 9.8 meters per second squared. So acceleration to gravity is equal to what? 9.8 meters per second squared. Now, work is done when a force moves an object. That is when work is done. Lifting an object against gravity stores energy as gravitational potential energy. I repeat myself. Lifting an object against gravity stores energy as what? Gravitational potential energy. And it's expressed with this formula. Work done is equal to mgh. Now, here, from the question, work done W is equal to mgh. Our m is what? 5 kg. So you have 5 times. Our g here is what? 9.8 meters per second squared times our height here is what? 3 meters. So we have 3. 5 times 9.8 times 3 will give us what? 147. Don't forget, work done is measured in joules. Therefore, the work done is what? 147 joules. From our options here, the correct option is what? Option B, with 147 joules.